Welcome back to the Federal Executive Forum on Federal News Network. We're talking about 5G and the implementation. Specifically, we're talking about priorities. Dan, I'm going to ask you, there's no question you have a lot of different initiatives going on. What are you focused on this year as far as your top, 2 or 3 priorities there?
Yeah, great question. So I'm going to cheat a little bit and give you 3 plus a cross-cutting one. Right?
Sounds great.
A little bit there, but so I think one of the interesting challenges here is 5G is so diverse, and all of our panelists have already touched on aspects of this. Right? We were just talking about MIMO and beamforming and all the stuff happening at the 5G radio access network, or the 5G RAN. And so on the radio access network, I think one of our top priorities really is spectrum agility and spectrum sharing. Right? At the physical layer, when we actually transmit the bits across across the air, there's a lot of contention for that space, a lot of contention for that spectrum. That spectrum is highly valuable. How do we appropriately use that spectrum, share that spectrum? And so one priority at the 5G radio access network, the 5G RAN part, is spectrum sharing. Mm-hmm. Second priority is going to take us in a different direction, and Darius did a great job of pointing out that 5G has a lot of wired connectivity. Right? We tend to think of 5G as it's that wireless transmission, and it is, but it's also the 5G core network. Was mentioned by a couple of panelists. Network slicing. What can we do on the back end once the signal reaches the tower? Can we put this on a virtual slice, essentially a virtual network on top of the network that could give us some added security, some added performance? And so on the core end, I would say that that network slicing and understanding better security in the core is our second key priority. And then the third one, just to make sure we fill out the whole 5G picture, right? So we could say 5G is all about the wireless part of the network, the spectrum, and it kind of is. Or we could say, no, 5G is all about the wired network and the back-end core, and it kind of is. Or we could say, really, 5G is all about the edge computing, the cloud computing, bringing that cloud to the edge. And that's also been touched on by several of the other panelists. Right? If we can get MEC resources, that 5G edge computing out there, we can do a lot more things that might be better suited for disconnected environments where we have, say, unreliable backhaul back to the cloud, to be expeditionary environments, even in a scenario where we have great connectivity back to the cloud, back to the generic the internet cloud throughout the world. Having that edge computing right there near the towers, right there near the edge, as the name implies, could give us additional benefits in terms of low latency processing that otherwise might not be possible. So those are my 3: RAN sharing, so spectrum sharing, spectrum agility on the RAN side, security slicing on the core side, edge computing, bringing that edge computing to the battlefield, in our case, in the case of DoD. And finally, my fourth bonus one in there is all of those are heavily dependent on getting security right. We can't share spectrum appropriately if we don't have security in at that level. We can't do slicing. We can't manage the core if we can't do security. That edge computing is great, but if that edge computing is not secure, very much limits its usefulness. So that's sort of our big picture, and I know that's a lot, but 5G is an interesting challenge.
Appreciate the top line there. Very interesting to see all those different pieces getting pulled together. John, top priority for Palo Alto Networks as you all look at 5G and this implementation that's going on across the spectrum. Dan gave us a very nice top line on the various parts that they're focused on.
Yeah, sure thing, Luke. 2 things to emphasize. The first one is about one of our very top priorities for the coming year, and that's about partnerships. We found that just like everything in security, partnerships are absolutely key to success. And these include partnerships with the 5G providers. Brian mentioned Verizon. We also have them with AT&T, Dish, IBM, and others. By the way, we just announced that we're partnering with Deloitte to offer clients in the US a new suite of managed security services for 5G. Kind of in an answer to the call of our customers who are seeking an expanded level of managed support for their programs. But another important partnership is the one I mentioned earlier, NIST's National Cyber Center of Excellence. It takes a teamwork approach to do this well, so effective partnerships are one of our top priorities for the coming year. But the second point, I have some advice for government organizations about priorities. As in most areas of cybersecurity, achieving success is another example of shared responsibility between governments and industry to collectively develop plans that are going to ensure that our critical lifeline activities that are enabled by 5G are appropriately secure, as we've been talking about here many times. So as government organizations seek to address concerns about 5G cybersecurity, I have 4 quick pieces of advice. Number 1, I would encourage the use of state-of-the-art scalable security tools and capabilities. Number 2, I would promote and incentivize ICT vendor best practices and transparency. Number 3, you should work with vendors that are open to shared responsibility between the ICT vendors, the telcos, enterprise owners and operators, and all of those that demonstrate best practices. And then finally, I recommend you promote automated sharing of actionable cybersecurity threat information among operators and other stakeholders for better situational awareness and prevention of successful cyber attacks.
Here on that last one, no question about that. I think we would all agree. Well, we only have a few minutes left, and we always like to wrap up the show and talk about what the future looks like. Brian, we're going to start with you at Verizon. You had talked about the implementation rollout of the 5G network there. What's it going to look like in a couple of years? 5G completely rolled out at that point? We're talking about 6G?
Yeah, I mean, it lays the foundation for obviously 6G on our 5G network, right? As I mentioned earlier, that we are excited that we'll start into 5G standalone core, get into network slicing. We'll open up the ecosystem even more. The C-band rollout will complete at the end of 2023, if not sooner, which is very exciting. And then we'll start looking at other spectrum assets to see where we can also deploy 5G as well, millimeter wave, right? So building out that network. More importantly, bringing the edge compute and working with our leading providers today, Amazon, Google, and Microsoft from an edge compute standpoint. And I think you're going to see the proliferation of application and use case. That's one of the biggest things I talk about 5G. It's very exciting to talk about the bits and the bytes, the RAN, but more importantly, what is the application or what is the problem or business outcome we're trying to achieve that 5G can actually enable, right? I think that is first and foremost, what are we actually trying to solve? So very exciting for the future going forward.
Thank you, Brian. John, how about at Palo Alto Networks? 2 years from now, what are you all going to be pulling out of the lab and putting into production?
Yeah, Luke, I think my vision would be about laying the right cybersecurity foundation. So as federal agencies go through their digital transformation and begin to embrace 5G networks with a focus on driving digitization, prioritizing the deployment of strong security posture is absolutely critical. And I think this requires 3 elements. 1, zero trust security. And we talked about this in a federal executive forum last month. Extending zero trust security into 5G with machine learning, next generation security capabilities is going to help protect end-to-end 5G infrastructure across all layers and key locations of this distributed cloud-native, multi-cloud 5G architecture. Segmenting 5G networks for zero trust access can also reduce the volume and impact of attacks. The second one is about granular visibility. And, going back to what Dan talked about in observability, one of the biggest lessons we've learned is you have to have real-time visibility. And I would argue that kind of cross-cuts, across the other functions of confidentiality, integrity, and availability. Legacy security approaches lack the visibility needed to prevent cyber attacks that target 5G networks. Comprehensive protection and context-driven security at scale is what's key to protecting 5G networks from attacks. And that requires granular visibility across all layers and at key locations of the network. So comprehensive protection of various federal agencies' infrastructure requires consistent real-time granular visibility and control across the 5G traffic that's passing through the network in real time. Based on the sensitivity or criticality level, this is going to provide the ability to identify and control the level of access that each device or user is granted, and which is also part of the zero trust approach. And then finally, automated security. You're going to have real-time automated security enforcement at the network level and device level, which is critical to a vision of the future.
No question that you're going to have machine speed type of capabilities to address these type of requirements. Stephen, how about you're actually in an interesting position there where you're testing and seeing a lot of this stuff way before it's going to get implemented. So what does that look like, and what does the future look like from where you all stand in regards to 5G and the full implementation of 5G?
Yeah, I would say automation seems to be
Yeah.
the key demand that we're seeing in a lot of the sort of work that's going on at the moment. How do we automate the networks to help them be more agile, but also to keep costs down, which you heard earlier on about the cost side of it. So we're seeing certainly a drive to bring more and more automation technologies inside the network, from how it's planned, how it's deployed, how it's operated. I think that's probably one of the key areas, and utilizing sort of early machine learning, maybe a bit of early artificial intelligence to drive that. I think what some of the innovative areas that I'm pretty excited about that we're starting to see as well is starting to think about using the radio network as a sensor in itself, so radio sensing. So we tend to think of the radio network and 5G as a mechanism for delivering our services, voice, video, data. But actually the radio itself provides a very rich set of additional information on the objects and the environments it's operating within. And we're only starting to sort of scratch the surface and realizing that that's a very powerful set of information that could be used to give tactical advantage. And I think that's a big area we're going to see more and more of. And the other, probably the last area is around, again, on the radio side of it, we've got early technologies called integrated access backhaul, which is basically where you're using the radio as a mechanism to, instead of having fiber installations where you can backhaul or daisy chain between cell sites to keep costs down. But I think we're going to see an enhancement of that as we start to realize there's opportunities here to have really rapid deployments where you don't need to have that in-ground fiber implementations, where you can actually use some of the available spectrum to actually create these mesh backhaul networks. And that sort of whole mesh network design starts becoming more and more prevalent, both in the public sector, but also in the military. And I think we're going to see a lot more of that there coming in the next number of years, because just with where we're seeing the early demand and the testing.
Interesting early insight on some of the things that are being thought about and actually tested. Looking forward to that. DeVarius, you talked about the Cyber Center. You've talked about getting a handle on the cost. Brought up some very interesting points. 2 years from now, where do you see the Army Corps of Engineers in regards to the use of this technology to enable, your mission?
Yeah, so from a Corps of Engineers perspective, we're a fully remote work environment. And so what does that mean? We're spread out throughout the various districts and divisions within the United States. And we have about, maybe before COVID, we were about 70%. I think now we've transitioned to about 90% remote work. And with that being said, I believe that construct will continue to be. So when you think 2 years from now, you think more in a hybrid concept, more workers working from many different areas due to the transition and transformation of COVID that has forced us in that way. So from a remote perspective, I see the enablement and the use of 5G technology to enhance the end user experience. So what does that mean? We have construction engineers at many different, not just construction sites, but we have engineers at levees, locks, dams, and those type of things. So being able to work optimally in a less controlled environment, but more so in a free space as an engineer, that's improving the end user experience. Those that are working from a remote location, having the ability to access not just data, but other mission critical elements, and then the need to share information with a lot of external partners. In 2 years, I believe from a 5G perspective, we will have significantly evolved in that space, and we'll definitely improve the end user experience, which will help from a Corps of Engineers perspective, our ability to deliver projects on time, within budget, and of quality, because I think that's ultimately what we're trying to do, enhance the end user experience through the leveraging of 5G capability.
Yeah, sort of real-time capability there locally really unlocks a lot of capability for your engineers, no question about it. Rob, how about at U.S. Air Force? It sounds like you all went through a early implementation phase in some of the air bases there. It looking like you're scaling up very nicely. What do you think it looks like in a couple of years? And I heard somebody talking about drones a little while ago. I don't know if that comes into play here, or what type of capabilities get unlocked with the Air Force once you start to implement these all across the world, I guess, in these bases.
Well, I mean, a lot of those capabilities already are in place. What it does is it enhances them. I mean, we already use drones. So what I'd really like to talk to is the hybrid world that we're about to move into. So one of the things that brought up private versus commercial. So for those truly unique pieces, yeah, we're going to look at private networks to solve, whether it's taking advantage of millimeter wave in a factory, or because we do have factories in Air Force or in maintenance facilities or whatnot. But there's so much to be used and utilized in the commercial piece. So one of the things that we're realizing more and more is both that we're not as special as we think we are. There's a whole lot of things that we thought that were uniquely DoD that may not be. And then there's a lot of lessons learned we're seeing in the world today about what commercial technologies can bring to you that being in a purely private model doesn't make sense. So, and I'm referring to the Ukraine, and look how Starlink was able to get capability in place very quickly and then mitigate issues very quickly. Not something you could typically do when it's a DoD-owned capability. We are not nearly as agile. So hybrid in that way, but also hybrid from this perspective of 5G. And it's one of the things that Brian touched on. There's going to be places where it makes sense for millimeter wave, going to be places where it makes sense for mid-spectrum, a lot of different things. So really, we need to really, and I'm coming back to this, really define our requirements, understand the use cases, what we're trying to do, so we're applying the right capability to the right situation. And I want to reiterate that because so many of the cases, we have people in the field coming back saying, I need 5G. That's not the requirement. We need you to come to us and tell us, hey, what is it you need? Because it's really hard to defend that in the budget. And it's hard for our vendors out there to understand, what is it I'm trying to supply you when you're just saying, hey, I need something. And then the last thing I want to reiterate is I really appreciated John's comments about security, but I would say more broadly, today's castle and moat model has been proven ineffective. So everything he said is not just about 5G. It is irrespective of the connectivity model you have in any and all situations. We need to be moving that direction.
No question about that. Well said. Dan, take us home from your perspective, looking at the sort of across the DoD spectrum. What does it look like in 2 to 3 years?
Yeah, absolutely. So I'll piggyback immediately off the zero trust comment there, and some of Rob and John and Brian and everyone. Right? So this really is critical. I mean, zero trust takes us away from that castle and moat, right? The castle and moat model said the bad guys are outside the network, on the outside of the network. The good guys are on the inside of the network. We've got this castle and moat that keeps us there. Especially when we move to a hybrid 5G world, where's the castle and moat? There is no castle and moat. There is no outside the network, inside the network. We really have to move to that zero trust, and as was already touched on, that information sharing is critical. That helps us get together. And as Rob was pointing out as well, right? We really have to be in partnership with the commercial agencies here. This is not. This should not be DoD go it alone. This or any agency go it alone. This needs to be done in partnership with our commercial partners. So just to kind of end with one interesting challenge from our side. So given all this, one thing I'm very interested in understanding what's going to happen in the next year or two. What does our network operations center or our security operations center look like in this hybrid world? So network operations center or NOC, security operations center or SOC. What does that NOC SOC look like in the context of Department of Defense 5G network? I think that's a really interesting question. I think that kind of cross-cuts a lot of what we're talking here. That includes that, because that network now includes that edge computing. It includes the spectrum issues. It includes the core network. How do we get all that? How do we get all that together? So I think that's going to be a really interesting challenge. And I would love to at some point walk into the knock sock for whatever deployment, whether it's commercial, whether it's DoD private, whether it's some sort of hybrid, and have that good understanding of this is what the network's able to do. And last, I'll just reiterate, stealing from Rob there, 5G itself is not a requirement. It's not, we don't want 5G. We want the technology that 5G can bring. And so understanding that and doing that in a secure way, I think is where we go in the future. So
right, and really focusing on the capability that 5G can bring versus 5G itself. Hey, listen, this has been a fantastic show, and I really want to thank all of you for taking the time out of your busy schedules to join us for this program. I'd like to thank the folks that sponsor us for supporting this show. I'd like to thank the good people here at Federal News Radio that make our program so successful and enjoyable. And most of all, I'd like to thank the listening audience out there that tune in every month. You've been listening to the Federal Executive Forum, part of the Federal News Network.